Welcome to the Explainer. Today, we're going to put on our detective hats to solve a medical mystery that, believe it or not, is still alarmingly common, even though you might think it's a thing of the past.
So our case kicks off with a 6-year-old kid. They're just not feeling right. They're cranky, their tummy hurts, and they're starting to struggle in school. Now, any of these things on their own, maybe not a huge deal. But when you put them all together, you've got a real puzzle on your hands.
The thing is, none of these symptoms scream one specific diagnosis. This means doctors can't just look at the kid and know what's wrong. They have to become investigators, digging for clues to find the secret culprit that's making this child so sick.
Okay, so every good investigation starts with gathering the basic evidence. In medicine, that means looking at the patient's history. And this is where we start to see the first crucial clues emerge.
The first thing you do is look at the child's environment. You're asking all sorts of questions. Could they be exposed to something from a parent's job, maybe at a battery factory? Is there a chance they have pica, which is a condition where people eat non-food items? But for our 6-year-old, a huge red flag pops up. They play in an old house. And old houses, well, they're notorious sources of old, chipping, lead-based paint.
All right, with a strong suspicion in mind, it's time to head to the lab. This is where a simple blood test can start building a really powerful case. We're about to go from a hunch to hard, scientific proof.
And here we go. The first lab report is in, the complete blood count, or CBC. You can see right away the hemoglobin is low. That confirms the child has anemia. But a good detective looks deeper. Check out the MCV. That measures the size of the red blood cells. It's also low. That's a huge clue. It tells us this is a specific type called microcytic anemia. And to top it off, the reticulocyte count is low, which means the body's cell factory isn't even trying to pump out new red blood cells to fix the shortage. Something is definitely wrong with the production line.
So what on earth does that actually mean? Well, just think of your red blood cells as little delivery trucks for oxygen. In microcytic anemia, the factory that builds these trucks is basically making them way too small, kind of like mini trucks. And a smaller truck just can't carry a full load of oxygen, which is why the body feels tired and sick. That CBC gave us a massive lead, but to really zero in on our prime suspect, the lab takes a closer look. They put the blood cells right under a microscope, and that's when they find it, the absolute smoking gun.
See those little blue dots? Yeah, they are not supposed to be there. They're basically bits of leftover genetic material that never got cleaned up properly when the red blood cell was being built. It's like finding a bunch of spare bolts and screws lying around on a car factory's assembly line. It's a dead giveaway that some kind of outside toxin is sabotaging the whole production process.
And seeing these little dots is absolutely crucial because it helps the detective rule out other suspects. For example, low iron can also cause microcytic anemia, but as you can see, the evidence just doesn't look the same under the microscope. With iron deficiency, you rarely see that stippling, and you might get these weird pencil-shaped cells instead. But with lead poisoning, you get that very distinct, prominent stippling. So let's recap. We have a history of exposure, we've got the specific type of anemia, and we have the classic microscopic clue of basophilic stippling. The case against our prime suspect is looking really, really strong. But in medicine, you need one final test to be 100% sure. And here it is, the final piece of the puzzle, the blood lead level test. If the stippling was our smoking gun, this test is the forensic DNA evidence. It doesn't just suggest there's a problem, it directly measures the exact amount of lead that's actually circulating in the patient's bloodstream. There's no arguing with this one. And there's a very clear line in the sand that doctors are looking for. In children, if that blood lead level comes back at 5 micrograms per deciliter or higher, that's it. That's the official threshold. That means action has to be taken. So, when you put it all together, the history of playing in an old house, the specific lab results, the telltale blood smear, and that final definitive blood lead level test, all the evidence points to one culprit. The case is officially cracked. The diagnosis is lead poisoning. And this slide just perfectly lays out the entire logical path our medical detective took, right? It started with a suspicion based on symptoms in the kid's history. Then they analyzed the blood for clues, which pointed them toward the one test that could confirm everything, and now they can finally move on to the most important step of all. Solving the case means taking a two-pronged approach. First, for really high lead levels, you can use a treatment called chelation therapy. It uses medication that literally grabs onto the lead so the body can get rid of it. But honestly, even more important than the treatment is prevention. The #1 most critical step is to find out exactly where that lead's coming from, like the paint chips in that old house, and get rid of it for good, so this never ever happens again.
And that kind of leaves us with one last really important thought. I mean, the main source of this poison was banned in the US way back in 1978. So why are we still seeing these cases? It's just a powerful reminder that the dangers of the past can stick around in our environment, hiding in plain sight in our homes, our water, and our soil, just waiting for the next victim. The culprit might be old, but the danger, for sure, is still very, very real.
Hi there, forest friend. Thanks for clicking on our video. We're so happy you're here. Before we jump in, don't forget to like, subscribe, and share this video with your friends.